Everyone knows about the North Pole, but not everyone realises how many different North Poles there actually are. As you're watching this video, you will already know about at least 3 of them: the magnetic North Pole, the true North Pole, and the North Pole that your compass actually points at. These 3 are the most important for navigation, and you need to know how to work between all 3. Let's start by working out exactly what they are. Compass north is probably the simplest to define. It's just the direction in which the compass needle points. It's got no physical location because the compass needle can be affected by any number of local conditions. The biggest component of compass north, though, is made up of the Earth's magnetic field, which leads us on to magnetic north. Magnetic north is the point on the surface of the Earth where the magnetic field lines are vertical. A compass needle, without any other external influences, should align itself with the Earth's magnetic field lines. Obviously, if you follow these lines all the way to the North Pole, you will reach the magnetic North Pole. As you can see from this image, the magnetic North Pole isn't fixed. It actually wanders around quite a lot. But the map itself does stay fixed, and by that I mean those grid lines. This leads us on to true north. True north is that point where the parallels of longitude all intersect. Of course, this is the navigational definition as we're defining true north so that we can use it on our charts. True north could be approximated according to the Earth's rotation, but it actually wobbles as well, so it doesn't truly define a fixed point. That is why true north for navigation is defined with reference to lines of latitude and longitude. So, now that we know what the different poles are, let's look at how we can work between them. Let's take the example of wanting to steer a course of 000 degrees true. We'll ignore set and drift for today so that we can focus only on the compass. We've calculated the true course according to the chart. If our vessel travels 000 degrees according to the chart, we're on track. But we need to turn it into a compass course so that we can tell the helmsman what to steer. For the first step, let's ignore local influences and assume that our ship's compass points at magnetic north. While our vessel travels 000 degrees true, its magnetic compass will actually be pointing towards the magnetic North Pole, not true north. The difference between the two is given on the chart as variation. And variation is defined as the difference between true north and magnetic north. You read it straight off the compass rose, and you can see in this case it was 13 degrees 0 minutes east in 2011. With a rate of change of -5 minutes each year. As it's now 2019, it's decreased by 40 minutes across those 8 years, giving a current variation of 12 degrees 20 minutes east. The way to think of this is that the magnetic North Pole is 12 degrees 20 minutes east of the true North Pole. Our course is 000 degrees true, so you can think of that as 000 or 360 if you've gone all the way around. To find our magnetic course, we want to measure our course from the magnetic North Pole instead. It becomes this distance around here. Mathematically, you subtract the variation from the true course, which becomes 348 degrees if we round it to the nearest degree. Instead of using the diagram every time, there is a useful rhyme to help you remember the maths. Variation east, magnetic least. Variation west, magnetic best. In our case, variation was east, so the value of the magnetic course will be less than that of the true course. We took 12 degrees away from 360 degrees, making our magnetic course less than our true course. We could tell the helmsman to steer 348 degrees magnetic, and we would know the vessel would travel 000 degrees true. If it's still confusing, stay until the end and we'll do some exam-style questions. Before that though, let's continue and turn our magnetic course into a compass course. Until now we've ignored local effects on the compass, things like metals on a ship and the magnetising of the hull and things like that. These all add together and they deflect the compass needle so that it doesn't point at magnetic north. We call this deflection deviation, and it changes depending on the ship's heading. You can find its value from the ship's compass card, which was provided by the compass adjuster when they adjusted the compass itself. We're going to use this example deviation card today. If the ship is heading north, the deviation is 4 degrees west. Now, Deviation uses the same concept as variation. It describes the difference between magnetic north and compass north. We think of it as the compass north pole is 4 degrees west of the magnetic north pole. Again, we've already worked out that our course was 348 degrees from the magnetic north pole. To find the compass course to steer, we want the bearing of our course from the compass north pole instead. As deviation is west, we add the 4 degrees to 348 to find a course of 352 degrees compass. Again, a similar rhyme works if you don't want to think of the diagram every time. Deviation east, compass least. Deviation west, compass best. So, let's look at a few different examples. First off, we want a course of 130 degrees true. Variation is read from the chart as 10 degrees east, and deviation we can read from the compass card as 1 degree east. For a full understanding, we're going to construct the diagram. Now, variation tells us that magnetic north is 10 degrees east of true north. Then deviation tells us that compass north is 1 degree east of magnetic north. The course that we're measuring is 130 degrees true. So the true course was this full angle, from true north all the way around to 130 degrees. The magnetic course is the course from magnetic north to our course, which is 130 minus 10, which is 120 degrees magnetic. The compass course is from compass north to our course, which is the full 130 minus 10 degrees of variation and minus 1 degree of deviation, so it's 119 degrees compass. For the second example, let's just use the rhymes. We want a course of 180 degrees true. Variation we can read off the chart as 4 degrees west, and deviation is 3 degrees east. We just construct the table and we work through. To find magnetic, we know variation west magnetic best, so magnetic will be more than true, so we add the 4 degrees to get 184. For compass, we know that deviation east, compass is least, so compass is going to be less than magnetic, so we take 3 degrees away from 184 to find the compass course is 181 degrees compass. And for the final example, let's do it the other way around. We measure a lighthouse bearing 270 degrees on our ship's compass. Our ship's heading is 135 degrees, and the variation from the chart is 5 degrees west. First, we construct the table with the information that we know. To find deviation, we enter the deviation card with our ship's heading, and we get a deviation of 1 degree east. Now, we can work through the table as before with either the diagram or the rhymes. As deviation is east, we add it to the compass bearing to get the magnetic bearing as 271 degrees magnetic. We can use the rhyme to check we're correct, deviation east, compass least. And finally, as variation is west, we need to subtract it from the magnetic bearing to get the true bearing. 271 minus 5, so you get 266 degrees true. And then we use the rhyme as the final check, variation west, magnetic best. The magnetic is indeed higher than the true, so we did apply it the correct way round. And that brings us to the end of today's tutorial. Hopefully it's helped you understand how to work between true, magnetic and compass bearings. Until next time, thank you for watching, and goodbye.